Hello, my name is Sarim Shehzad. In this video, you will learn about the benefits of using Smart I/O to connect your electrical assets into a cloud-based network, and most importantly, I'll show you how to do it. So let's get started.
The first thing we need to look at is traditional I/O and data acquisition systems, so we can understand the need or advantages of new modern ways to collect and share data. Traditional I/O systems consist of local networks which are controlled from a centralized supervisory control and data acquisition systems, or what we call a SCADA system. SCADA systems consist of a network that employs I/O modules to control devices. They would normally be based on either serial or Ethernet communication standards. Serial uses protocols such as Modbus RTU, Profibus, or CAN bus. Ethernet-based networks use protocols such as Modbus TCP or Profinet. I/O devices look like the modules shown on the screen. I/O devices function as the hardware that collects and transfers the data from all the sensing devices connected into your network up to the processing system that monitors and executes the commands to control the network. For each pin, you have either an input or an output. The inputs can be used to read the status of any device, and the outputs can be used to control the device. I/O modules used in SCADA systems can be deployed wherever a process needs to be automated, for example, from basic building management systems to complex assembly lines found in manufacturing facilities. These traditional SCADA systems are widely used but have some disadvantages. To manage these networks, you will have to be present on-site as remote access can be an issue. Also, backup on these systems can be problematic. They are centrally controlled and all the data being generated is stored on a local server. This means if the server fails, you might lose your critical data without the chance of recovering it. These systems also use proprietary software which are normally tied to a specific manufacturer. Therefore, integration with other networks can be difficult and time-consuming. So how can we overcome these challenges? Well, technology develops at a fast pace, and we must take this to our advantage. Emerging technologies such as cloud-based systems are currently very popular, and that's exactly where we need to look at to leverage our networks and systems. Implementing a cloud-based system in our industrial environments will help us overcome most of the challenges that we face with traditional I/O systems. With cloud-based I/O, you don't need to be physically present on site. You can control and monitor your assets remotely no matter where you are in the world. Most cloud-based technology use IEEE standards, which makes devices made by different manufacturers interoperable. And most importantly, you can have peace of mind with reliable cloud backups. Now coming on to a bit of a different but related topic, the Internet of Things, or IoT. A cloud-based SCADA system can be taken as a perfect example of Internet of Things. One of the main goals of IoT is to have everything connected so that you can see and control your assets no matter where you are in the world. So how can we connect I/O systems to the cloud? You can connect your I/O modules to the cloud by connecting your SCADA system to the internet, or by connecting your I/O devices with built-in cloud connectivity to a cloud-based SCADA system. Now, what protocols are used for cloud communication? The most commonly used protocols for cloud communication are MQTT, XMPP, and AMQP. But the most popular among all these protocols is MQTT. MQTT stands for Message Queuing Telemetry Transport and has gained its popularity for several reasons. It is efficient, extremely lightweight, requires less bandwidth on the network, and it's very secure when combined with encryption protocols. This protocol employs a publish-subscribe method. The MQTT protocol defines two types of network entities, a message broker and a number of clients. MQTT clients include publishers and subscribers. Let me explain this further. Under this model, the broker collects data from the publisher on a specific topic and sends it to all the subscribers who have subscribed to the topic. As an example, in the industrial environment, the publisher sends data such as temperature or pressure to the broker, and the subscribers to any of these topics receive new values every time there is an update. In conclusion, if we combine I/O and IoT technologies, we can control our systems remotely through the cloud, meaning that we could be anywhere in the world and still be able to see what's happening to our assets or control them.
Here I have the Moxa IoThings modular I/O demo unit with built-in cloud connectivity feature. Now I'm going to show you how you can use this device to connect your electrical equipment such as your sensors or switches to the cloud. The Moxa unit here will act as a publisher. In real-life applications, this will be connected to your sensors or switches or any electrical equipment that you want to manage remotely. The laptop here will be used as a subscriber to subscribe to the topics being sent by the publisher. Both of these are connected to a local broker. Your broker server could be a cloud-based server or it could be local. For this demonstration, I'm using a local server. First, you need to log into the IoThings demo unit. To be able to do that, you open your web browser and then type in the default IP address, which is 192.168.127.254. Once you've done that, type in the username and password. And once you've logged in, let's wait for it to log in first. And yeah, so once you've logged in, under the security settings, you'll find MQTT client. You need to make sure that it is checked. Then, under protocols, you will be able to find the MQTT. Click on MQTT and specify your broker's IP address. As we're using a local broker, the IP address of our broker server is 192.168.127.23. After making sure that you have changed these settings, restart the device so that all the changes are made. Once that is done, you should be able to subscribe to your publisher. So for that, we're using a client called MQTT Lens. Here, add the connection and specify the connection name. Let's say we call it test. Then you need to specify your host name, or in our case, it will be our broker IP address, which is 192.168.127.23. After you click on the create connection, here you should be able to see this is green, which means it's connected. Now here, we need to subscribe to a topic. Our topic names, for example, in our case here, because I had restarted it, so it's asking me to log in again. I will log in, and here I'll click on MQTT. Under topic settings, you can find a list of topics. First, ensure that the topics that you want to subscribe to are enabled on the publisher. As you can see, the rest of the topics are disabled, which means even if you subscribe to them, you won't be receiving any updates. So after enabling them, here you can see a topic name. So I will copy this topic name and paste it here, where I can see that it requires a topic name. So I've subscribed to it. Now I can see a connection has been established. This means that every time there is a change with this input, it will send a notification to the client. So if I press a button, here I received a notification saying that something has changed, which means the status. Now under here you can see the value is 1. Now if I turn it off now, and click here, again, I'll see the value is 0 now. This can represent anything. For example, if you have a door connected to this input and you want to monitor how many times that door has been opened or closed, you can receive notification every time that door has been opened or closed. Now, after all of this, we can see that I have some of digital outputs here, which means I can control those outputs using the publisher built into this client. So for example, this is an output and I want to publish a value from the client and control my asset. So here I can publish to a topic, which means the one that I copied from here, if I paste it here, and I will have to obviously specify what I want to publish. So for example, I want to change a status of any output. In our case, it could be a bulb or could be a fire alarm or it could be anything. So I'll assign it a value equal to 1. And once I publish it, you will see the output here has changed. Now you can change this value to on or off. I turned it on, now I'll turn it off. And that's how you can control your assets or monitor your assets using MQTT. Thank you for attending our online masterclass. If you would like to get your hands on the Moxa IO Things demo module, you can request a demo unit by visiting the web page displayed on the screen. In addition, if you would like to learn more about the concepts explained in this video, you can read our latest white paper. A link to this document and additional resources can be found in the description of this video below. For any further information about our process control and automation systems, please visit our website or give us a call. Thank you for watching.